Hey guys, it's us again. Welcome to Petals for your troubles.
And today we'll be helping you with acoustics, specifically Doppler's effect.
So get your pen, paper, and calculator and watch the video.
The security alarm on a parked car goes off and produces a frequency of 960 Hz. The speed of sound is 343 meters per second. As you drive towards this parked car, pass it, and drive away, you observe the frequency to change by 95 Hz. At what speed are you driving? There are three cases to choose from, or three formulas to choose from in the Doppler effect. The first one is when the observer is in motion, the second is when the source is in motion, and the third one is when the observer and the source are in motion. So since we have a problem that involves the observer moving, we will use case 1's formula, which is apparent frequency equals frequency of the source multiplied by velocity plus minus velocity of observer over velocity. Along with the problem, we'll put the meanings of these variables on the upper right side of the screen so you guys will be guided, and we'll also place the given there. Now this equation can actually be interpreted in a more expanded way. F times V over V plus minus VO over V. Now since V over V basically translates into 1, we can change the equation into F times 1 plus minus VO over V. Since the problem states that the observer both went towards this parked car and drove away from it, we need to have an equation that involves both positive and negative VO. And since we weren't given F, but given the change in F, we'll relate it to that given. So the change in F equals F apparent times 1 plus VO over V, close parenthesis, minus F apparent, open parenthesis, 1 minus VO over V, close parenthesis. Now through simplification, math, and just basic factoring, we'll cancel out 1 and then combine the two VOs, which will give us apparent frequency, open parenthesis, 2VO over V, close parenthesis. So that's the change in F. Now the problem's asking for what speed the observer is driving at, which is VO. So our goal now is to isolate VO. So we multiply both sides by V, cancel that out, rewrite our new equation, and then further isolate VO by dividing it by 2 apparent F. Cancelled that out, and then we finally isolated VO, which gives us our final equation of VO equals change in F times V over 2F apparent, or apparent F. So that's the equation we need to get our answer, and after this we'll just need to substitute it with our given and we will get the velocity of the observer. Now referring to our given in the upper right side, we'll just plug everything in. So 95 times 343 over 2 times 960. Do the math on that one and we'll get 16.9, which will give us 17 meters per second. And that's how we got our velocity of the observer.
And that's it!
I hope you learned something new about the acoustics. See you next time.
Don't forget to like and subscribe.
Okay, bye!
Yeah.